Good afternoon, friends. Thank you for being here. We are happy to connect through WhatsApp. Remember, you are in the tall classes. Why tall? Because technology is for all and because all of us need it. Since you are all new to this format and this class, let me remind you that you have to keep your mobile phones switched on, not off. We have already given you the link to the WhatsApp group. You can put all your questions in WhatsApp chat whenever you want. Please do not ring. We do not accept calls from students. If you get disconnected by any chance, please log in once again to the link that has been sent to you. Every one of you can connect on my WhatsApp number 9818951003. We start today's class like every day with a small prayer praising the eternal Guru, for the Guru, the Almighty, is not only our creator but our ultimate teacher.
Gurur Brahma Gurur Vishnu Gurur Devo Maheshwara Gurur Sakshat Parabrahma Tasmai Shri Guruve Namaha Tasmai Shri Guruve Namaha Tasmai Shri Guruve Namaha.
We had learnt in the last classes that a product becomes smart when they are fitted with tiny microprocessors. These are semiconductor chips that are basically that help process data like computers. This data could be visual from sensors and cameras with multiple functions. The data can be also audio, used for diagnostic and prescriptive analytics. The data can sense temperature that helps to get the condition of the product and the process. The data can also predict odor sense, which shows the health and the chemical changes. You see, if the smell changes of food, then you come to understand whether the food quality changes or not. Similarly, motion data can tap speed, acceleration and give relative changes of a product moving. The direction data can also define positional placement of the device. To become smart, all things must be fitted with microprocessors. These are tiny electronic components which are programmed to perform all the instructions and tasks needed to make a device work as intended. The devices also need to have their own IP addresses and have to be connected with the internet. We must understand that they must have the sensors for measuring and monitoring the temperature, color, odor, speed, direction, or any other element that can help them function autonomously or remotely. This is how smart things of the IoT world operate. Everything in your home, your car or your office can be accessed and operated remotely through IoT today. Gadgets like mobile phones and computers and televisions are already connected to the internet and function in a smart way. Others, such as your home lighting, air conditioners, deep freezers, toasters, dog collars, door locks, and so forth, they can all start becoming smart when they are fitted with microprocessors. For example, you can stick an Amazon Dash IoT button to your washing machine or your dishwasher and order detergents automatically. Now, you have to see your existing devices to understand this. Now, you have a mobile phone. Check how your mobile phone is linked to other devices. Go to settings, open the connected devices, and then click Smart View. See your phone on the TV and vice versa. Connect to Galaxy wearable devices. Monitor smart TVs, light bulbs, appliances, and others. This is all written on your smartphone settings. So you have not done it yet. Now try to do it now. Make devices respond to conditions. Turn on lights with the door opening feature, the air conditioners remote, the phone, use the phone for the managing the air conditioners, deep freezers in which have meat and fish, their condition, quality you can understand. Even your toaster, whether you want a crisp brown toast or a soft toast, you can command through phone your Alexa or any other smart device how you want to have it. Door locks. Yes, Alibaba's Khulja Sim Sim is possible today. You can from a distance tell your door lock to open and your door will open for you. Let me give you a glimpse of your unutilized power that you have. You are simply not being smart because you don't understand technology of IoT, and when you go to these phone settings and go to the connected devices, let me show you how it works. Here is your connected devices. Now you go over there. Here now you can see over here Smart View. Then there is Galaxy wearable. Wearable means these are the watches which are the smart watches. This is the Smart View. In the Smart View, if you go, you will find that show on your phone, show your phone on a TV, view your phone screen, or play videos on a nearby TV. Watch your TV on your phone and watch your phone on your TV. And monitor the quality of playback. Now all these features are there, so you can easily use them, and these are various smart things which are there in your phone, which you have the option. You can control your devices, monitor and control smart TVs, your light bulbs, your appliances and other devices. You can make these devices respond to all conditions. When you go to the bathroom, you can turn on the lights while the door opens, so that in the night you don't have to grope around. You can make your life smarter, and you can be smarter this way. Try it and you will find that your life changes as you understand what IoT is all about. You understand what the smart world is all about. The entire world is becoming smart because they understand the technology. So start understanding the technology, start loving the technology, and start getting into the technology. You can be the smartest person in your household if you understand how all your gadgets operate, how the technology operates, and how this entire life around you is changing. This is a futuristic world. This is not the world of tomorrow. So be updated and try to improve your quality of life by being updated. You are buying gadgets which are worth thousands, but you are not utilizing them. You are only utilizing 10% of your gadgets. Why? Why should this happen? Why are you not utilizing the power which you have? Just because you don't understand technology. So learn IoT and update yourself.
Number 3. Internet of Things, IoT. The Internet of Things, IoT, is all about creating a connected network of physical devices, from smart refrigerators to industrial sensors that collect and exchange data. IoT applications are driving efficiency in industries like healthcare, manufacturing, and transportation, but security vulnerabilities are a growing issue. With more devices getting connected, cyber attacks targeting IoT systems have surged. Despite these challenges, the IoT market is forecasted to reach $1.6 trillion by 2025, making it a pivotal technology in smart homes, cities, and industrial processes.
Now, if your refrigerator was smart and had IoT devices for recording the temperature and the condition of the products within, it would transmit real-time data of its contents. This data would tell you how the number of perishables in your refrigerator fares. It will tell you the quantity, it will tell you the temperature and the condition of all your vegetables, meat, apples, milk, beer, and cooked food stored within. With all that information, you would have an enormous amount of data because it would convey this data and store this data on a minute-to-minute basis. So this cannot be stored in a small computer or in your mobile phone. So what it will do is it will transfer this data to the cloud server. We have heard about cloud servers before. These are servers, big server banks which are there all over the world, and because they can be accessed from anywhere, they are called cloud servers. Now, all this smartphone data which they go to the cloud server and then comes back to your smartphone, because your smartphone memory still does not have the capacity to take all those data. For this reason, it is not given to your limited memory of the smartphone directly, and it needs to be transmitted through connected devices to the cloud. You could also choose to let the information directly flow to the supplier of milk or vegetables or meat, that okay, my groceries have run out, so it does not only give me a feedback, it gives the feedback also to your smart supplier of milk or groceries, and that would completely free you from the daily core of purchasing products and instead permit you to spend your evenings enjoying yourself with your friends and families. Smartphone driven IoT wearables, household gadgets help you play music at your home whenever you feel you are in a lighter mood, or whenever you feel you are depressed. You can change the color of the lights. The refrigerator has freezer options which go continuously work behind you without any human intervention, and all this memory goes to the cloud and is accessed by the smartphones. And it will also help you remove Blinkit from your life, because every time you are ringing up Blinkit, you are wasting your time and energy. So your smart world will bring IoT over there, who does all this dirty business of your supply chain management. Whether you have milk, or whether you require butter, or whether you require meat, everything comes through a IoT managed device. So you did not make any effort yourself. Now, have you all seen Batman's stories? Batman, he is a beloved technology freak if you are keen on movies, and he is one of the superheroes who uses technology and is an early adopter to IoT in the movie The Dark Knight. Remember the movie The Dark Knight? He fights the Joker by using his special power of echolocation. He sees the world around him through a mobile phone and through the mobile phones of others. They act like cloud servers for Batman. So this is where the technology is going. Some of the Silicon Valley investors, some people, who know where the technology is going, like Peter Levin, he says that one day all cloud servers will go away. You can store your data into your smartphone. You need not store your data on cloud servers. You can be like Batman. Everything can come to your smartphone, and this will give you an unlimited capacity, unlimited storage capacity, and you can act as a self-contained data bank with data portability features. Although you cannot still teleport like Batman with his bat helmet, you can try to understand what he is doing, because tomorrow you will be able to do that. Now let me tell you why I am saying this. It is very simple. Because today there is a world of driverless cars. So what is happening in the driverless cars? It is not going to the cloud server. The data is coming from the opposite side of the road, how the traffic is moving. So there is no time for the data to go to the cloud servers, get processed and come back to you. So instead what is happening is that there are edge computers in those smart cars, and those edge computers located in the cars process the information instantly. So this is what happens, and this is how the world is moving. So if you don't do this within another 5 years time, if you don't understand all these things, you will be left behind. That is why we are bringing technology for all classes, so that all of you can understand the implication of technology, where the world is moving, and how you should spend your time updating yourself in technology. Even if you are not an engineer, even if you are not a scientist, you must only know enough science of a class 9 student, and it is for all of you, for the men, the women, the old and the young. Everybody must understand that we are entering into a new phase, into a gadget world, into a smart world, where we will totally become dinosaurs unless we update ourselves in technology. So attend the tower classes and do update yourself continuously, because we have assessments also, and you will come to know how much you have actually learned and what you can actually do.
Back in 2009, Google actually launched this as a self-driving car project. Yep, originally this was called Project Chauffeur. Between 2009 and the end of 2015, the company had spent $1.1 billion on developing its self-driving software and hardware. And in December 2016, they renamed it Waymo. The first licensed self-driving car in the US was Google's 2012 modified Toyota Prius. However, the original Google autonomous car design was called Firefly, a bubble-looking car which launched in 2014. The original designs included $75,000 radars, but these dropped 90% in price when Google started designing them in-house. They took a Jaguar I-Pace and they fitted it out with all of the latest LiDAR, camera and radar technology on the car. Now this is so cool because this one up here can literally detect objects 3 football fields away, which is just insane. LiDAR sends millions of laser beams per second out onto objects to build a detailed picture of the world 360 degrees around it. The radar technology is used to determine how far away the objects are and their speed, while the cameras detect visual information, like if a traffic light is red or green. It can still detect objects perfectly well. Even in the fog, when it's heavily raining, it can still do all of that. Now, the reason why they started in Arizona, right, because we're like, why do you start there? Is because the weather was good. Then they came to San Francisco, where there is rain, there is fog, there is lots of other weather conditions. So now, slowly, what they're doing is building up the fleet. Waymo's focused on retrofitting existing car models like the Jaguar I-Pace and the Chrysler Pacifica. Their next car will be custom built with Geely.
Radio frequency identification or RFID tagging is considered as a precursor to IoT. This technology involves the use of radio frequencies to track and identify items. Now, what is a radio frequency? Radio frequency is the oscillation rate of an alternating current or voltage of a magnetic or electric or electromagnetic field. It varies from something like 20 kilohertz to around 300 gigahertz. Hertz is the frequency. It is the standard of frequency. This is roughly between the upper limit of audio frequencies that humans can hear and the lower limit of infrared frequencies, and also encompasses the microwave range. Now, this technology involves the use of radio frequencies to track and identify items. RFID reader device is connected to a network that can send or receive signals via radio waves. Once an item is activated, then it can send signals to the reader which are transferred into data. So what happens? It is these signals, electromagnetic signals, which gets transferred and into data. This data can include things such as the name, the description, the condition, the amount and the location of the items. If there are 50 items you want to tag, then that is the quantity or the amount. If the location is in Sri Lanka or the location is in France, then that is the location data which you have to give it. So RFID tags are used in modern passports, in ID cards. For example, to store information about the holder, such as their name, date of birth, photo, passport, expiration date, etc. This information helps to identify the holder. Now, when you go to the airport, they will scan your ID and instantly it opens to a wide data bank which they have, in which the suspected people are already segregated. So if you are not amongst their terrorist suspects or other suspects, you are let through within seconds, because this is all technology working at the back. Now, all these technologies which you are using or which somebody is using to assist you, you must know about them, because you must know that what is happening. So you must know what is RFID, what is radio frequency, how does one create a frequency ID, where are RFID tags used. So all these things you must know, and it is so interesting because since you travel by air, and these also travel by air, these radio frequencies, and they cover a wide spectrum. They are used to create unique patterns and are distinctly identifiable and can be tagged. RFID tags, it forms a wireless communication that incorporates the use of electromagnetic or electrostatic coupling in radio frequency portion of the electromagnetic spectrum to uniquely identify an object or a person. So it uses the radio frequency to search, to identify, to track and to communicate with items and people. Now there are multiple applications of this RFID, which is very interesting. That is the interesting part that you come to know. Now there are low frequency RFID tags which have a short read capability, and they have a short read capability of 10 centimeters and are used for livestock tracking in poultry or in animal farms. Now, if you have visited New Zealand, you will see that there are thousands of sheep which are being reared. Now, every time a tourist bus goes around those farms, those sheep come to the gate and show themselves. There is nobody that is herding those sheep. The sheep are automatically going. So every time a tourist bus comes, why does the sheep come near the tourist bus? It is kilometers of farmland in which these thousands of sheep. What happens is that there is a RFID tag with each sheep, tracking the sheep. That RFID instructs the sheep how to go, where to go. It is all done by a control room. So all the sheep, there is no shepherd, but it is being monitored by RFID tags. And these are short read capability RFID tags, and which are used for livestock tracking. It is very unique, but visitors can look at them, and on RFID prodding, when the RFID tag prods, then they go out to graze, and when it prods again, they come back to their home without any human monitoring, without any human intervention whatever. It's amazing. Now there are high frequency tags which have up to range of 1 meter, and these are used for security locks, locks on doors, credit card payments, electronic ticketing and data transfer. So all these are again high frequency tags, and they have a range of 1 meter. But the cheapest variety and the cheapest type of RFID tags is the ultra high frequency tag. They are in millions. And why and where do you find the UHF tags? They are used for inventory tracking. Inventory tracking, you understand? When you go to a shop, each of these shops give you a piece of cloth. Whatever, when you come out, you have to give that cloth to the counter, and they will take out that RFID tag and keep it. And if they don't take out the tag, and if you go with your shopping bag to the gate, there will be a beep, and you will be embarrassed that you have bypassed the store. We'll talk about it more after a few seconds. See at this video.
Smart Pass. You give all your information, especially your face recognition information, and then you like.
It uses your Face ID on your phone. You register your boarding card, you scan your QR code, and then it recognizes your face as you go in, so they don't have to do the passport check.
Exactly. It's just like boo. It's just like you just go in and you're in.
RFID has been in use for more than 50 years by retailers and logistics firms. The tags are very useful for managing inventory, so a store can know how much of each item they have and where to locate them. So this is a very cheap sort of inventory management procedure which has been adopted worldwide, because these UHF tags have a long read capability of up to 100 meters. So anywhere at the range of 100 meters it can be read. So it is very useful for a store to manage it. So what happens? Let me tell you this. This is very interesting. The tags are used for managing inventory so that a store knows how many items are there and where they are located. So when you go to any shopping mall and buy an item, what do? You buy a clothing, or the salesperson at the billing counter removes the RFID tag once the product is built. Now if the RFID tag is not removed, as we saw in the video, it will beep and embarrass you at the exit gate. Now this RFID tag has not been attached by the storekeeper. Really, it has not been attached by the storekeeper. It has been the companion of the product right from the inception. Now let us say the fabric of the jeans sold by a global brand comes from Mexico and it is stitched in Vietnam. So what happens? The RFID tag comes from Mexico, it goes to Vietnam where it is stitched. The jeans are then sold in India, Bangladesh, Philippines and Indonesia. Now the RFID tag records all the operations during the procurement and processing of the fabric, including its cutting, dyeing, washing, stitching, labeling, packing and shipment. Everything, all these processes are noted by the RFID tag, and the entire movement across the nations to each and every storage and distribution network, and finally to sales. All this information is related and is relayed to a centralized computer. Now this is a huge, humongous number of data, but this is how it is done in modern stores. Now all this goes into a centralized computer and it helps improve the supply chain transparency and also identifying the carbon footprint of each item. You see, suddenly you will find that some store declares that this is a green item, means this is an eco-friendly item. This is because they have been tracking their supply chain sources and trying to make it eco-friendly. It doesn't happen on its own. You know, they'll remove all the plastics, they'll remove all the nylons, and they will try to make it only cotton. Then they will try to see that it is done in machines which are eco-friendly, which are energy saving devices. It goes through a process where mostly renewable energy is used. Then they say that this is an eco-friendly product. Now, smart devices use both RFID and barcode technologies that need scanning. They are used for tracking things and tracking personnel, as well as providing unique identification, controlling access to restricted areas, and even surveillance. Now, this RFID manages the global supply chain. It integrates location and it responds with data and at speed. Now, how did this RFID tag start? The person behind this, of course there were many persons, but one of the persons behind this was Kevin Ashton. He was the executive director of a research group, Auto ID Labs at MIT. And he was reportedly the first to describe the Internet of Things. 2 decades ago, while making a presentation for the consumer giant Procter & Gamble, he had introduced the RFID tag, the same gentleman. So Kevin Ashton had then said that today computers and therefore the Internet are almost wholly dependent on human beings for information. Those days, 30 years ago, it was the humans which were typing out all the information in the computers. So nearly all of the roughly 50 petabytes of data available on the Internet were first captured and created by human beings by typing on the computers and then pressing a record button. So that is how it was recorded. And it was first captured by humans and then recorded, and it had limitations of time and accuracy. And it had limitations of attention also. You see, somebody using the computer, somebody makes a mistake. So all this would go into the data chain. So he said that all this is not a very good way of capturing data in the real world. So what he said is that if we had computers that knew everything there was to be known about, and they used the data without any help from us, we would be able to track and count everything and much faster and reduce the waste and the loss, and the cost would be lower, because the computers, instead of the human processing, the computers would themselves record the data and would place the data. We would know when the things needed replacing, repairing or recalling, and whether they were fresh or past their best. Now that is 1990, when Kevin Ashton used wireless devices to transmit data and used the RFID tags first. In 2000, Ashton, again at MIT Labs, talked about the IoT taking over from the RFID. So the IoT is the next generation of RFID tags. Although Ashton believed that RFID tag was a prerequisite to the IoT, and according to him, all devices were tagged, computers could manage to track and add them to the inventory. But it was later discovered that things that were initially tagged by RFID tags could be better accessed if they were fitted with IoT microprocessors directly. So we'll talk about it, and you must see this video to understand it.
So one of the first Internet of Things technologies is RFID, or radio frequency identification. And one of the interesting things about RFID is it's a microchip. An RFID tag is a microchip with an antenna and no battery. Where does the energy come from? The energy comes from the radio wave that is talking to the microchip. That chip needs so little energy because of Kumi's law that we can turn it on and off simply by communicating with it. So the other prediction we can make is, in addition to computers becoming invisible, a lot of computers will not need any apparent electricity whatsoever. They will get their energy from the radio waves communicating with them. They will get their energy from ambient light. They will harvest their energy from vibrations in the air.
So let us recap what we have learned in this section. A product becomes smart when they are fitted with tiny microprocessors. What are these microprocessors? These are semiconductors or chips. We have heard of so much talk about semiconductors and the fact that all over the world people are trying to put up semiconductor plants. The US is trying to keep leading the semiconductor race, and it is asking Taiwan and Korea, South Korea, to shift their semiconductor plants in the US, and we know that China is trying to catch up in the semiconductor manufacturing process. So semiconductors, or the chips, basically process data like computers. They are small. These microprocessors, they are fitted with the semiconductors, and what this does is it processes data, it stores data, and this data could be visual data from sensors and cameras with multiple functions. This data could also be audio data used for prescriptive analytics, and this data could also sense the temperature or the odor, the smell, which shows the health and the chemical changes which are happening in any organic or vegetable product. And it can also sense the temperature, the heat, which could tell you the condition of a running machine, and it can also sense the motion data, which can tap speed or acceleration or give the relative changes. It can also define the direction data and the positional placement of the device. So these are all things which a smart product can do, and that happens only when they are fitted with smart products. Now, like gadgets of the mobile phone era, the computers and the televisions are already connected with the internet and functions in a smart way. Other at home, you see, we did not have smart lights before. We used to have one light which was a use and throw away light. So now this has become a smart light. So if you want to tell the light to dim, it will dim. If you want it to change color, it will change color. You have to just give a message to the Alexa or to your mobile phone and it will change color. So similarly, your music system, it can play the music as you want. You have to just speak on your phone or on your Alexa and you have to just tell them and they will behave as it is. Maybe you are not feeling well, so you want a different music, you want a different lighting in your bedroom, and maybe you are feeling very jubilant and you want your mood to reflect in your house. You can do that. So all these things can be done through your mobile phones, and this is what we told you over here, that your mobile phones can connect you to your door locks, to your toaster, to your smart TV, and they can connect to your wearable devices. Now this is a huge amount of power which you have and which you have not utilized. Just open your smartphone and you will find that there are so many connected devices. Go to settings, you will find the connected devices, and over there you will find that you have not used any of these. So why haven't you used it? Because you never knew it. You don't understand technology. So these things where you can monitor and control your TV and your light bulbs and your appliances and other devices, they are all there in your phone, but you are not connecting it to it. Similarly, smartphone driven IoT wearables. What is a wearable? An Apple Watch is a wearable. A Samsung Watch is a wearable, which if you are going jogging, it will record the number of footsteps which you are taking, and it will also tell you how your heartbeat is, how your pulse is functioning. So all these are wearables, these are household gadgets which we wear on our wrist. Now your refrigerator, it can operate without any humans. Nobody has to look inside and say that the milk is over. The gadget does it itself. That is IoT. And you don't have to call Blinkit ever, because your IoT manages your groceries. It only tells your supplier when you need the thing instead of you having to think about it. So that is how the smart world is. Now we also talked in this chapter about how Batman, our movie hero, uses this technology and this data transfer, and how he uses his bat helmet, and instead of using the cloud servers, he collects data from the telephones or the mobile phones of others, and he fights the evil in the movie Dark Knight. So this is also what we talked about, is showing you that how cloud servers, though they are indispensable today, could be threatened if the mobile phone batteries become such good receptors that it can hold a lot of data. And we are going to that, we are going over there. Now we also talk about the history, that how we got to IoT. We first saw the RFID generation, in which the radio frequency tagging was done, and it was done with the animals in the animal farms which we saw, and then it was done with your credit card machine and with your ATM. And finally it was done in the stores where all your shopping goes through RFID checks. So this is how we went through RFID, and then finally from this RFID we came to the IoT stage. IoT stage does not require RFID, but it also uses the same technology that devices connect automatically and give a feedback of the user to the processor, and that is how it works. So we will talk about it in the next technology for all classes. Till then, please go through what we have told you in the videos, and we will come back again, and have a good day. Bye bye.